So hey guys, welcome back to the channel. This is a physics buddy and today we are going to discuss the mathematical aspect of projectile motion. Yes, all those equations of projectile motion, we are going to derive those relations. We are going to understand that how those relations came. In order to understand this, we need to understand or we need to have a prior knowledge of vectors. I'll attach the link in the description section, so make sure you watch it out if you haven't seen it before. So let's get started. In the last class, we start unit 4 that is projectile and 2D kinematics. So we'll be continuing with that only. We'll keep talking about what is projectile and how its motion takes place. So in order to understand all these things, what you need to keep in mind that there are certain relations that can be derived by actually understanding the motion of the projectile. So if you remember in the last class, I told you that projectile motion is simply referred to the object. So basically when an object is thrown at an angle theta, when an object is thrown at certain angle, that object is referred as projectile. So that is what we need to keep in mind. So that object is referred as projectile. So projectile is just a name which is given to the object. That object can be anything. It can be whatever you can imagine. If it is going up and down, we can say it is going in motion. So that can be referred as projectile. Again, the most important part, this is a two-dimensional motion under gravity, because the motion takes place due to gravity. If there is no gravity, so we cannot even imagine that how object moves. So that is what we need to keep in mind. Although I already gave you a little bit of idea about how things work here in projectile motion. So let me just give you that quick recap. So I just told you, suppose you have thrown an object with certain velocity at an angle theta. Let us consider its velocity to be u, and the angle which it makes with the horizontal line is supposed to be theta. This is horizontal line, or this is something we can call ground. So whatever angle the projectile's initial velocity will make with the horizontal line, we can call it theta. So there are a few things that we need to understand. The first here is the time. But how much time that object will take to come back to the ground. That is something referred as time of flight. Then we also talk about the maximum height, like up to what height that object will move up. Similarly, we also talk about horizontal range, like what is the displacement that particle is going to do in x-axis. So the displacement in x-axis is referred as horizontal range. The displacement in y-axis is referred as maximum height. So today we are going to look at all these terms from the mathematical point of view. We'll derive relations between these, between all the different physical quantities we have learned so far in kinematics, that is velocity, acceleration, displacement, time, and all. So let's talk about it. Let's talk about the equations that we are going to use in projectile motion, which you have already seen in the class, but today we'll see that how those equations came. Before that, what you need to keep in mind, all the three equations of motion we have learned. So V final is equals to V initial plus acceleration times t. Similarly, talked about displacement. We can refer it as x minus x naught is nothing but V initial times time plus half of acceleration times t square. Similarly, we talk about V final square minus V initial square is nothing but 2i's of acceleration times displacement. So all these three physical equations which we learned in the kinematics, we are going to use these equations only to derive the relations for maximum height, time of flight, and horizontal range. So let us talk about these equations. And before that, there are few assumptions that we made in order to talk about projectile motion. The first thing is the particle remains very close to the Earth's surface. So if it is very close to the Earth's surface, the acceleration due to gravity will not change. It is supposed to be constant. Similarly, when we are solving these problems, the air resistance is supposed to be not existing there. We just neglect it. Similarly, the distance that projectile travels is very small, so that Earth can be treated as a plane surface. We won't treat Earth as a curve like this. We will treat it as a plane surface. Why? Because the distance which this projectile is going to cover along the horizontal line, it is going to be very small as compared to the surface of Earth. So we can take it as plane surface. So these are the few assumptions that we make in order to talk about projectile motion, and that is something you need to keep in mind. So the first we'll start with time of flight. So as I already told you, the time of flight is something which is referred as the time for which the projectile stays in air, or you can say the time for which the projectile stays above the ground. That is referred as time of flight. So for whatever time it is above the ground, we call it time of flight. So let us try to find out that what is time of flight and how can we actually calculate it. So in the last class, if you remember, I just told you that whenever we are solving the projectile motion, we try to solve the projectile motion in two different axes individually. So we have x-axis, similarly we have y-axis. So we solve the motion along both the axes simultaneously. Like As I told you, in x-axis, there must be some initial velocity, which can be written as vi. Similarly, in y-axis also, there must be some initial velocity, which can be written as vi. So if it is in x-axis, we call it vix. If it is in y-axis, we call it viy. So we already know how the velocities will be there in x and y axis simultaneously. So this u is making an angle theta with the horizontal. So this u must have two components. One component is along x-axis and one component is along y-axis. This component along x-axis can be written as vix. Similarly, the component along y-axis can be written as viy. This vix is what? We already know this thing. We already resolved the vectors in the two dimensions. So we know that if there is any vector and we make an angle theta with the x-axis, the component which lies in that axis is going to be v cos theta. Similarly, the component away from the theta is referred as v sin theta. So we'll use these terms only and we'll put these terms here only. So the initial velocity in x-axis is v cos theta we can write, and similarly we can call it v sin theta. Similarly, I also told you all the remaining things here. Apart from this initial velocity, we can talk about acceleration in x-axis. We can also talk about displacement in x-axis and so on. So in y-axis also, acceleration in y-axis, we'll talk about displacement in y-axis also, and that too, we'll talk about displacement in y-axis for complete journey as well as for half journey. So just let me mark the points. This is O, A, B, and let me call it C. So the journey is from A to C. We'll talk about displacement in y-axis, that is going to be different, and if it is from A to B, it is again going to be different. So these are the few things that we already discussed in the last class. So you have to keep these things in mind. Displacement in x-axis is referred as range, and in this case, it is going to be AC. Similarly, displacement in y-axis, if you're talking about the complete journey, it is going to be 0. Also, if you're talking about the displacement in y-axis from A to B, so we can simply see that this is going to be the height. So we can also write it as h max. So these are the few things that we discussed in the last class, and using these things only, we'll find out the equations of projectile motion that we have here. Now, we are going to find out the equation for time of flight. In order to find out the equation for time of flight, we need to keep this thing in mind that there must be a physical quantity which relates both the x-axis as well as y-axis. Or you can say the motion in both the dimensions will be related through one physical quantity that is called time. So we can use time to relate both the axis x and y, or we can also relate motion under x and y axis simultaneously using time. So finding time is the very crucial thing. How can we find it? Just try to remember the equations of motion we have here. We have only three equations of motion, and out of those three equations of motion, only two equations of motion, that is this as well as this, have time in it. So using these two equations only, we can find out time. Now, if we talk about the first equation, it has final velocity, and this final velocity is not something that we know or that we calculate as of now. So we'll drop using this equation. We'll use the second equation of motion to find out time in this particular scenario. So if you just look at the given equations or given information we have here, the displacement in y-axis for the complete journey is going to be 0. So we'll use that thing only. So as we know that displacement in y-axis is 0 for complete journey of the projectile. So if it is 0 for the complete journey, I can write Sy is going to be 0. That is for A to C. So if we substitute the values here, so we know Vi into T plus half of A T square is going to be 0. Now this is going to be Y because we are writing equation for Y axis. So VIY is supposed to be V sin theta. So we can simply substitute V sin theta here. As it is in upward direction, so it will be taken as positive. Remember this. Into time plus half of acceleration in y-axis is supposed to be negative of gy because gravity always acts in downward direction. So we'll take it as negative. T square is equals to 0. So if we solve this equation, we'll get half of gt square is going to be v sine theta times t. Right? If we cancel out the t from both the sides, we'll have time here, which can be written as, so gt by 2 was supposed to be equals to v sine theta. So here time is going to be 2v sine theta by g. That is the equation for time of flight. Or you can say, as we're talking about for the complete journey. So this is the equation which represents the total time taken by the projectile. So it is the total time taken by the projectile to reach the ground back. So this is the equation which you can directly use to find out the time of the given projectile. Similarly, we need to understand one more thing here. Whenever we are talking about the projectile motion, so the time for which it is going upward and the time for which it is going downward, they are always equal. I already told you this thing when we are talking about motion under gravity. The time of ascent is always equals to time of descent. That is something we need to keep in our mind. The time of ascent is always equals to time of descent. Now, if you relate this thing with the practical world, you might feel that it is not the right thing. It is not the same. But here we need to understand this fact that the assumption we made while understanding or while talking about the projectile motion is that there is no air when we are talking about the projectile motion. So because of that, if there is no air, time of ascent and time of descent will definitely be equal because gravity is constant. So it must have to be equal. So I can say this total time is nothing but time of ascent plus time of descent, right? So from here I can say this t is equals to twice of time of ascent. The time of ascent can be written as cap t by 2. This t is already we have calculated, which is v sine theta, 2v sine theta by g divided by this 2. So this 2 will cancel out the 2 in the numerator and we'll get time of ascent as v sine theta by g. So this is the time for which the particle will move up. That is another important thing. This is the time for which projectile moves in the upward direction. Similarly, if we have to talk about time of descent, it is also going to be v sine theta by g, where this v is what? This v is the velocity with which we have thrown this projectile vertically upward. So always remember these things. The time is very important thing here in projectile motion because this is the only thing which is going to relate both the axes together. Let's move ahead. Next, we have to talk about maximum height. See, once I share these notes, make sure you write these derivation part by yourself. Writing this derivation will definitely help you to solve numericals. Once you are solving questions in the class, it will become very easy if you know how this relation came. Instead of
Okay.
directly using those relations, we need to know that how these relations came. So next thing here we have is maximum height. So we already know if we want to describe this maximum height, so we can say it is the maximum possible displacement. It is the maximum possible displacement
Wait,
that
last topic was called time.
last topic was, yes, it was time of flight.
Okay.
Now we're going to talk about maximum height. So if we define maximum height, we define it in this way, that is the maximum possible displacement in vertical direction. So whenever someone is asking us to calculate displacement in vertical direction, we have to calculate the maximum height that projectile might have reached. So how can we do so? Now, first of all, we have to understand that whenever we are solving anything, we have to first of all think that which equation we have to use and which axis we have to involve. So here, as we know that this is the maximum vertical displacement. So here we have to use motion in y-axis, or we have to apply equations of motion in y-axis. Now, which equation should we use here to find out maximum height? Obviously, it should be the displacement equation. So we have to use the displacement equation. Now, if you look at the equations of motion which you have, so here we have two equations of motion which involves displacement. The first is S is equals to V initial t plus half of at square. And the second we have is d final square minus V initial square is equals to twice of as. So these two equations involves displacement in it. But as we know, we don't have the final velocity, so we will drop using this third equation. So we'll use again the second equation of motion. Now, in order to have the use second equation of motion, we need to have the given things here. So initial velocity in y-axis, we already know it is nothing but v sine theta. Time is already something we have calculated. Calculated for which part? For this part, for A to B. For A to B, it is going to be time of ascent, and this time of ascent we have already calculated as v sine theta by g in the last page only. Acceleration is going to be negative of g. Again, time is going to be v sine theta by g. So we'll substitute all these values in this given equation and we'll have the equation for maximum height. So here we will write, we'll be solving motion in y-axis and using second equation of motion. So this second equation of motion can be written as h max is equals to what is v I y? It is v sine theta. What is time? It is v sine theta by g. Similarly, acceleration is negative of g and time is v sine theta by g, that too whole square. So if we simplify this equation, we'll get h max as v square sine square theta by g minus half of v square sine square theta by g. Can I write only g here? Because this g in the numerator will definitely cancel out one g in the denominator. So we'll be
Yeah.
left with only one g in denominator. Now, if you solve this equation, if you just look at the numbers here, if you look at the variables here, isn't it something like 1 minus half?
Yeah. So I just
So if
want
it is something like 1 minus half, so it is going to be half. So I can simply write sine v square sine square theta by 2g. So this is going to be the equation for maximum height that this projectile is going to show us. And this is the equation which you use. So this is the initial velocity. So with whatever velocity the particle has thrown, we can find out that to which height it goes depending upon the following factors. The first is initial velocity and second is angle of projection. So I can say here h max depends on first initial velocity and the second angle of projection. So if we know these two things here, we can find out h max. If we don't, we have to somehow find it and put the values in the given equation. That is how you can solve it. Is it clear?
Mhm.
Let's move ahead. Now let's talk about range. So as I already told, that range is nothing but it is the maximum displacement in horizontal direction. Horizontal direction means we're talking about x-axis. So the particle starts from this point A, reaches to this point C. So this displacement in x-axis, it is referred as horizontal range. So we have to find about this, we have to find this horizontal range here. Now it is quite clear that we're talking about the horizontal axis, that is x-axis. So we must use motion, equation of motion in x-axis. In order to find out range, we have to use equations of x-axis. Now which equation should I use? Again, if I use the third equation to find out the displacement in x-axis, we need final velocity. But as we don't have final velocity, we'll use second equation of motion again. So I can write here using second equation of motion,
Mhm.
Sx can be written as v initial in x-axis into time plus half of acceleration in x-axis into time square. As we already know that acceleration in x-axis is always zero because the particle never moves in x-axis on its own. You have to push it up a little in order to move it in x-axis. So we just ignore it. The x-axis acceleration is going to be zero. If we substitute the values here, so it is something that can be written as range. Sx can be written as range, which is equals to what is the initial velocity in y-x-axis? That is the horizontal component, which is supposed to be v cos theta. Always remember this. Whatever component of velocity is there with the theta or along theta, it is going to be v cos theta, and whatever component of velocity is along y-axis, it is going to be v sine theta. So here you can write v cos theta times time. Now what is the time? What is the total time here? But the projectile goes from A to C. We already saw the total time is twice of v sine theta by g. So we'll substitute this value directly here in this equation, and we can have 2v sine theta by g plus, as acceleration is zero, so there must be nothing. So it is going to be v square twice of sine theta cos theta by g. If you solve this, if you know this, twice of sine theta cos theta is nothing but sine 2 theta over g. So this is going to be the range, and this is how you are supposed to write it. So this is the maximum displacement that particle does in x-axis, or we can call it this is the maximum horizontal range. So again, you can see that this maximum horizontal range depends upon the two factors again, that is the initial velocity and the angle of projection. So we can say again that it depends on velocity as well as angle of projection. So if you have these two things with you, you can find out horizontal range as well. Does all these things make sense?
Yeah. Mm. So time, maximum height, and range.
Yeah. And I guess you have already saw these equations before as well, because you were
Yeah.
telling me these equations in the last. But the main thing is you need to understand that how this equation came. If you know the process that how this equation came, you can easily solve any question. But if you remember these equation and then you try to solve the question, it might not be possible that you solve each and every question. So this is the way that you should learn. Although, let's move ahead. Let's do some questions, because here you will understand that how questions differ in all the cases. So the first thing here is you have given that there is a projectile and it is thrown at an angle theta with some initial velocity u. So the question is write an equation of velocity in x-axis with time. So the question is asking what is the velocity in x-axis, and that too as a function of time it is asking. So if we already know this thing that this velocity have two components, and along the x-axis is its component ux, I can write as u cos theta, right?
Mhm.
So we have to talk about this velocity as a function of time. As a function of time means that after certain time will this velocity change. You just have to think it in this way. Whenever the question asks what is the equation for this given variable with time or as a function of time, so you just have to first of all verify that will this variable change with time. So as you can see here, as we know that acceleration in x-axis is nothing, it is always zero. So can I say this, that if I use the first equation of motion, so final velocity in x-axis is always equals to initial velocity in x-axis plus acceleration times t. So if you just look at this equation, so can you say that velocity in x-axis is always equals to u cos theta? Because it will not depend upon time, it will not depend upon acceleration. As there is no acceleration, so the equation of velocity with the time in x-axis is always going to be a constant one. So this is something we can call a constant thing which doesn't change with time. But in y-axis it do change. And how we can refer it that it is changing? By simply looking at the path of the projectile. As we know that when it is going upward, it is going like that. So why at certain point of its journey it not going further upward? Because the velocity at this point, or you can say that the vertical component of velocity at this point becomes zero. Or you can say that the velocity in y-axis at this point a is zero. That's why it is not going up further. That's why, because of gravity, it is coming downward now. So just keep these things in mind. It will definitely help in certain problems if you encounter them. Let's move ahead. Now the question changes, and it is quite, you can say, a similar one. But now the question says, what is the velocity in x-axis with time? What is the velocity in y-axis with time? So we have to talk about the velocity in y-axis. So again, remember, using first equation of motion, we can write that the velocity will change as acceleration is there. We already know that acceleration is always acting in the downward direction and the initial velocity is always u sine theta. I can write it this way. So the final velocity as a function of time is always equals to u sine theta plus ay is nothing but negative of g times t. So this is what the relation of velocity in y-axis with time. Remember the difference. Remember the difference. Vx is nothing but u cos theta only, whereas Vy is u sine theta minus gt. It means that it is variable quantity. So velocity in y-axis is variable in case of projectile motion, whereas it is going to be constant. Why Vy is variable and Vx is constant? Because acceleration always lies in y-axis. Because acceleration always lies in y-axis. That is gravity. We already saw this in the free fall case. So that is something you can say it is an extended version of free fall, because here you have throw an object at certain angle. So that's why you can consider it as a again a free fall case, but velocity is at some angle theta. So that's why all those things change a little bit. But if you put the value theta is 90 in each of the following relations, which we just saw like in range, in maximum height, and in time, we'll get the similar relations just like those you learned in free fall case. So this is again another case. One more question to you. So the question says express the equation of vertical velocity. Vertical velocity means velocity in y-axis in terms of height. In terms of height. So how can we write it? Let us try to understand. So we already saw this thing that velocity in y-axis is something which we call v sine theta. And if you talk about the displacement, or you can say the maximum height, so h max can be written as v sine theta times t plus half of a by t square, right? We already saw this relation that this h max is nothing but, in place of this v sine theta, I should write vy only, because we have to write this vy in terms of h. So I'm writing it as vy times t. What is the time? What we found as a time? We found v sine theta by g plus half of negative of g v sine theta by g whole square. Now, if you just look at this equation once again, this is v sine theta is again vy. So I can write vy square by g minus vy square by 2g, which is going to be vy square by g. This is the relation of maximum height in terms of vertical velocity. Or you can also write vy as, there should be 2 also, vy as 2gh whole under root. So this is what is being asked in the question. Again, all these things are very relevant to your syllabus. All these things are, you can say, will definitely help to solve problems in the test as well as in the class. So just make sure that you understand each and everything. If there is any doubt, anything, just ask.
Mm.
Let's move ahead. One more question. So just think of it and tell me what should be the correct answer. The question says what is the velocity of the object at the highest point of its trajectory. So what velocity the object possesses at the highest point of its trajectory?
You would probably need to use H max.
We are talking about this.
Mm.
No, no, that's not the case. The question says what is the
Yes.
velocity at this point, specifically at this point.
Oh. Um.
Just try
Velocity
to
of the sun.
remember what we did in the first class of this projectile motion.
Mm.
Just try to observe. This is something I already taught you in the last class, but once again, just try to observe. So suppose this was the point from where I throw an object with some initial velocity u at some angle theta. At this point, this particle possesses two velocities. One is velocity in x-axis, that is going to be u cos theta, and one is velocity in y-axis, which is going to be u sine theta. Now just think and tell me at the highest point of its journey, out of these two components, which component will be there?
The U sine theta.
So you are saying that u sine theta will be here. So the velocity in y-axis is still here. This is what you are saying, right?
Mhm.
Now just tell me, if u sine theta is there and u cos theta is not there, isn't it should be like that the projectile should go like that? It should not
Oh,
even go further.
yeah. So it's both.
Just think of it. Yeah, just think of it practically. Now let's try to understand that how the velocity changes. If you look at the u cos theta, we always know that it keeps on moving ahead, moving forward like
Mm.
that. It keeps on going, right? But if you talk about the u sine theta thing, it is maximum at this point, or you can say it is maximum at the time of launch. So what happens here is that due to gravity which is acting in downward direction, it keeps on reducing. U sine theta keeps on reducing. So this decreases. And as it starts decreasing, at this particular point, Vy becomes 0. That is the reason why it is not going upward anymore. If Vy is there, the projectile should go like that, but it is not going that way. It is because it doesn't have any velocity left in the upward direction to move it up. So here, the answer to this question is that velocity of the object at the highest point of its trajectory is only x component of velocity, and that x component is nothing but u cos theta, or the cos component of initial velocity. So we'll simply say that the answer to this problem is going to be cos component of initial velocity. That is the reason why we see object moving forward, not upward, at the maximum height point. This is the point where the object is at its maximum height or maximum vertical displacement. Did you understand this part?
Yeah.
All right, let's move ahead then. Now the question says, what is the change in velocity within a given time period? Like how we can actually talk about the change in velocity in the given time period. Now, again, we have to understand the motion of the projectile. So at any given time interval, if I say at any point at the same height, I already told you that whatever velocity the particle possesses at this point while going upward, that velocity will always be equals to at the same height when it is going downward. So when we are talking about change in velocity, the change in velocity will depend upon theta, this angle. So this is a supplementary thing. I don't think so that is going to be asked to you. If something like that is there, just tell me. We'll discuss it then only, because it involves a lot of calculations associated with vectors as well as finding out resultant. So I don't think so that should be there in your syllabus. So let's just skip this question and move ahead. Just remember this part. Whatever velocity is there at a certain height while going upward will always be equal to the velocity at the same height while the same projectile is going downward. So the
Okay.
magnitude of velocity at both the points will always be equal. So I can say VA, mod of VA is always equals to mod of VB. Why I'm using mod? Because velocity is a vector quantity. In order to avoid or consider the direction, I'm using mod. So this is the only thing that you should remember from this particular part. Let's move ahead. So the question says, determine the velocity of the object when it is at half of its maximum height. So what is the maximum height? What we talked about maximum height? It is V sine theta by 2g, or V square sine square theta by 2g. This was the maximum height. So the question says, what is the velocity? So if this is maximum height, h max, so half of maximum height is going to be this. So I can consider this as the point P, where we actually have to find out the velocity V. We have to determine this velocity. This point is h by 2, right? So let us try to figure it out that what are the quantities we have given here. Again, we have initial velocity in y-axis, which can be written as u cos theta, u sine theta. We have given the displacement. The displacement in y-axis is going to be h by 2. Initial velocity in y-axis is going to be u sine theta. We have to find Vy, that is the final velocity in y-axis. Do we have time? No, we don't have time. We'll try to find out time first, then we'll move towards the other thing. So now that is an interesting part. The time for which the projectile takes to reach from point A to the maximum height point B is not going to be the half of for which the particle takes to reach the displacement h max by 2. That is one such case. So we cannot consider time to be half of it. But yeah, height is already given, it is h max by 2. So we can use one such equation. First of all, let's see. So Vy, using first equation of motion, can be written as Uy times Ayt. So if we have to find Vy, I can use the third equation of motion directly here. Let's see how. So I'll write using third equation of motion. Vy square minus Uy square is going to be twice of A, that is going to be minus of G, and displacement. So displacement in vertical axis is going to be h max by 2. It is given in the question. So from here, Vy is going to be Uy square. This minus will come positive there, and it is twice will cancel out twice. So negative of G H max under root. So Vy can be written as U sine theta square minus G. H max is what? H max is this. It can be written
Mm-hmm.
as V square sine square theta by 2G. So G will cancel out G. If I solve this equation, just look at the problem here. So Vy can be written as, so is it like U square sine square theta minus U square sine square theta by 2? Like something again, 1 minus half. So it is going to be half. So U square sine square theta by 2 whole under root. So Vy is going to be U sine theta by root 2. This is going to be answer. Now this is not the easy question, or you can say this is not something which anyone can do in the first go. But yeah, if you understand each and everything, you know how to play with equations, you know how to use and how all these things work, you can easily solve it. So
Mm-hmm.
just focus on solving different type of problems here in this part. If you are able to solve different type of problems, you're good to go. These are not that much difficult. Again, we are using those three equations of motion only. It's not like that we have done something else. Whatever we have learned so far, we are using that only. So
Mm-hmm.
that is you need to keep in your mind. Let's move ahead. Now let's take few seconds and try it out. The question says, what is the angle of projection at which horizontal range and maximum height of the projectile are equal? So here you just have to find out the angle for which this horizontal range is equals to h max. So use this relation where this horizontal range is equals to h max, and just let me know what should be the angle. Try it out. What is the relation for range?
The V squared. Wait, how do you say it? You say V squared 0
V square 0, not 0.
or
It's
not?
initial velocity, square of initial velocity. Just say it like that.
Okay.
Square
The
of initial
square
velocity
initial
times
velocity time times sine 2 theta
sine
divided
2
by G.
theta over G. It should be equals to
Squared of initial velocity times sine squared theta divided by 2G.
exactly. So this velocity squares will cancel out, G will cancel out. Sine 2 theta can be written as twice of sine theta cos theta, which is
Mhm.
equals to sine square theta by 2. So this sine theta and the square will cancel out. So we'll have 4 is equals to tan theta. So theta is going to be tan inverse 4.
Yes.
That is how we got this relation, although that was good.
Hmm.
Now here are a few questions, and I would suggest that you should try these questions as a part of your homework. You have a huge time to do this.
Yeah.
I'll be sharing these questions in the form of notes with you. So just make sure you try these questions. These questions are now pretty easy. Just have to substitute the values and you'll be able to solve it. Now this is an interesting one. Try this as well. If you have any doubt, we'll discuss the same in the next class.
All
And
right.
I guess by the next class, you must get some assignment based on this projectile motion. So if
Yeah.
something like that is there, just let me know. We'll discuss that assignment. We'll do some problem on this topic so that if you do some problems, it will give you a confidence about this particular topic. So let's
Okay.
keep it till here only.